Welcome everyone to this Connect with Remedy webinar recorded session. Today we're going to cover Remedy 9 Overview Console Performance Considerations, and Rajeev Patel, a senior product developer, will take us through this content. Rajeev, go ahead.
Thank you, Greg. Today's topic, as Greg mentioned, is Overview Console Performance Tuning. And in the last few years, especially the last year and a half, we at BMC have been encountering issues with Overview Console performance, and we've been, the performance team has been engaged in helping customers tune their Overview Console performance, and there are a few tips or a few tricks that we have up our sleeves to basically get the Overview Console working better. Of course, the word better is subjective because it could go from maybe 2 minutes down to 30 seconds, and even 30 seconds may not be acceptable, but certainly we can make an attempt to improve that performance. So let me begin today's presentation by talking about the agenda. I will show what a typical Overview Console query looks like. Your query might be different from this a little bit, but the bulk of it, the skeleton of it should be similar. We will identify the key tables that are involved in the Overview Console view. It's a view in the database. We will generate an execution plan for the original untuned query. We will go ahead and create indexes as we need to, as have been identified in the tuning process, generate a new execution plan, and then we'll end this presentation. But before we get to the bulk, the core of the tuning process, let me explain a little bit what the Overview Console is. As most of you are aware, the Overview Console is a multi-way join, and it's called a view. It's called a join form in AR, but it's a view in the database of select ITSM tables. Key tables, I've realized different customer sites over the years, the key tables usually tend to be help desk, work order, task, and some customers do use problem and change predominantly. And so these are the big hitters. Help desk generally tends to be a very big table, as most of us know. That's the one that stores our incident tickets. This particular presentation is based on actual customer data. This is a large customer. It's a pretty large customer that uses Oracle as a database, specifically Oracle RAC. And we will start with their Overview Console untuned query, and we'll try and tune it and see what happens to it. And as I mentioned before, this customer is on Oracle 11.203, which is why the in-house database where I generated data for this presentation is also an Oracle 11.203 database. This methodology can be applied to an MSSQL database. Of course, the explained plan that I've used in this example doesn't work on SQL Server. You will have to use a different way to get your query plans, but the query plans are easily accessible and acquired using SQL Server's SQL Management Studio. And it's a graphical tool. You can also get a non-graphical output for the execution plan, but I prefer the graphical plan. So, disclaimer, caveat emptor. The Overview Console is used differently at different customer sites. And by this I mean some customers favor help desk, as I've mentioned before, while some customers might end up favoring work order or task or change or problem. Also, the Overview Console itself can be configured to have what I would like to call SubConsoles. So I've seen customer sites where when the user lands on his or her Overview Console, there are actually 2 or 3 or even 4 sub-consoles or sub-pods, if you want to call them. One might be displaying change, another one might be displaying work orders, the third one might be displaying incident tickets, and so on and so forth. So that is one of the tips that I have for general or console tuning. Unless that user needs to see all 4 or all 3 or all 2 pods, it might make sense to have that user land on on a screen or a console that he or she works on pretty much all day. So for example, if you have a help desk user creating incident tickets, it might make sense to have that user land on only the incident console, as in not the incident console, but on the overview console showing incidents. Or if that user is only using work order, you might want to see only work orders on that console. So you might want to go revisit your users and have users show only data that they need for the day or for their day-to-day work. So basically, I get asked this question: why doesn't BMC already ship indexes on these forms? The overview console, as I mentioned in the slide before, is a multi-way join. The base forms that are involved, there are 10 of them. And as I mentioned, the big hitters are help desk and work order and task and change and problem. And there are others also. So there are about 10 forms that form this union. BMC doesn't know how you as a customer are going to be using the application, ITSM, and what needs you have for the overview console. So in your case, if it's, let's say, release management or change, you might want to tune your own environment based on change or release management and specific to your data distribution, specific to your data volumes. So BMC does not want to ship too many indexes because having too many indexes might affect performance in some of the sphere, of the application. So basically, the overview console ships out of the box with the bare minimum indexes that we know work for pretty much all customer sites, and then you would have to create additional indexes as needed to customize to your environment. So here is a typical overview console query. In this case, T5619 happens to be the view, the overview console view, called SHR:overview console. And in this case, this particular customer is using change, help desk, task, knowledge, known error, and problem. And this is what their users end up using, and this is what their business use case is. These are the ones that they're using, and I've color-coded them. Basically, change is in red, help desk is in light green, task is in light blue, and so on and so forth. Problem is in dark blue at the end. And the last condition there at the end of the SQL, the 60900, like HS038431, that pretty much looks like it's a user ID. And the 60900 is one of the columns in the tables that is used for row-level security checking, as is the 60901 and the C112 columns. So these are used for row-level security checking in your ITSM application. So I used Oracle's explain plan to generate an execution plan for that SQL that we just saw. And as you can see, key operations have been highlighted in red by me. The first operation ID that is important when you're tuning is operation ID 0. And as you can see, the second last column on the right, it's the cost column. And the cost in this case is 3,611. And the aim of this entire exercise will be to try and reduce that cost. You can go read up more about what the cost entails, but the cost, loosely speaking, is how much it is going to cost Oracle to satisfy this query when we run the query, when it is run in the database. And the cost comes from a whole host of underlying contributors. Basically, the cost computation comes from stuff like how fast it takes to read a single block on disk, what your multi-block reads are, what your data distribution is, how selective a certain column is. And so all of these contributing factors, they can be, how do I put this? They can be actually, you can give the Oracle Optimizer more information by gathering statistics, which is why database optimizer statistics are a very, 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 very important role. They play a very important role in SQL performance in your database, whether it's your Oracle database or it's a SQL Server database. SQL Server has its own costing mechanism, and basically it's similar to the Oracle costing mechanism. The more the data you give the Oracle optimizer engine to work with, the better choices it will make when it has to come up with an execution plan. So for the current execution plan, the cost is 3,611. We can see that there is a full table scan on line number, on operation ID number 17, though the cost is low. The cost in this case is 2. And we'll get to why that cost is low for this particular query. The next part is line number 37. The cost is again kind of low. It's a full table scan on T1674. We have operation ID 51 in red on T1852. Again, it's a full table scan. Cost is low again. Out of the 3,611 cost, the major contributor was in step number, operation ID number 66 and 67, which is basically an index range scan on table T1908. The next one was, I would say, step number 72, the second last one on this page. The cost is 166, and it's a full table scan of T1976. So, this is the execution plan. A typical Oracle explain plan gives you not just the actual operations that are being performed on the different tables, but it also gives you the predicate information, basically what happened in those steps. So as, you know, this is a pretty long predicate information. It's spanning multiple screens. So when this is made available to you online, you could go through this with a fine-tooth comb if you like. So I'm going to skim through this. And I'll explain to you why I'm skimming through this, because I'll be taking the example of step number 66 and step number 72 and explaining to you what this predicate information gives us in terms of information and how to use it. So I'm going to skim through it. Basically, all these steps, we have detailed information of what's happening there. And in loosely speaking, the information is filter and access, which is the same kind of information you will get for an MSSQL database. When you're looking at the SQL Management Studio and looking at an execution plan, you will see what the object was to access the table and what the output was and what the filtering conditions were. It's the same kind of information can be obtained from the graphical execution plan in SQL Server. And so I'll skip ahead to the next slide, which is basically tuning. Well, the next slide before we get to the actual tuning. As I said, the overview console is a multi-way join. For this particular customer, this was the data distribution. The overview console, that first thing on top. The overview console has 10,429,682 rows. The bulk of these rows are coming from help desk, which is the last line in red on the screen, T1908. 7.5 million rows are coming from there. Task, the second red line from top, T1190, is contributing almost 2 million rows to that. Another 817,000 rows in the middle are coming from change. And the other tables are loose change. T1976, the second last one on the bottom, has 9,951 rows, almost 10,000 rows. And the other tables are small tables, either no rows. For example, AAS activity, the second from top, has 0 rows, and a couple of the other tables have 1 rows, and the other tables have maybe 200 rows or 1,000 rows. So they're not contributing much to either to performance, slowness, or to the overall rows that are in the overview console view. So now let's get back to that first operation that we were talking about, which is on T1908. As you can see from the previous slide, T1908 is the last row in red on the bottom, and that's got 7.6 million rows almost, and it's a heavy hitter. It's your help desk form, the one that stores your incidents. So if we go back to this, we can see that it was doing a range scan on an index called T1908_old. And the predicate information says that this particular index was on column C1000079 and the column C7. The C100079 column, if I remember right, is the assignee group ID, and the C7 column is the status column. I could be wrong, but I think that's what the name of the column is, and that you can confirm you can look up in Dev Studio, or you can look up in an AR schema in an AR admin table called field, and you can put in the schema ID and the field ID, and it'll give you the name of the column. But loosely speaking, you can see that the overview console part that deals with the help desk part is in green, and that comes from that first slide, which where I had the typical overview console query with different color-coded sections which refer to different parts of the query: help desk, change, problem. So this is the help desk part, and as you can see, the column 230009 is equal to main help desk, and you're running a query on the 79 column where there's an OR condition, and you can see that it's checking for SGP 121189 or SGP 121208. And just looking at it, I can assume that SGP stands for support group. So I suspect the 10079 column is support group ID, I think. And then it's checking for a column C10003561 greater than 0 or less than 3. And so in this case, we're looking at the 100356 column mapping eventually to the base table, which is help desk, to the column C7, which is status. So what I did is I ran a simple query where I did accounts distinct values for this C1079 concatenated to C7, concatenated to the C230009 column, and I found that there were 5,537 distinct values in a table that has 7.5 million rows or 7.6 million rows. So I decided to go ahead and create an index in that order, and I regenerated the explained execution plan for this query. And please note that on top, in red on this screen, the cost was 3,241. That was the cost for this particular operation. And so when I regenerated the execution plan, I wound up getting the overall cost for the query. If you remember, the overall cost was, if we go back a few screens, I'll just run through it. The overall cost for the query was 3,611, out of which 3,241 was coming from step number 66 over here on this screen, and that's the one we are tuning right now. Going back to that screen, 3,241 was the initial cost. After regenerating, creating the index, which you can see on top, there's the syntax for that. I created the index, and the cost for the overall query has come down to 363, and the cost for this particular step has gone down to 11. So we're no longer seeing anything in the 3,000s, obviously, because the overall cost for the query is 363. And and you can see it's picking up the index that we created, T1908 BMC. So that took care of the help desk part. The second contributor was 166, and that was a full table scan on T1976. And T1976 in this case is problem investigation. Again, we can see that it's got a set of conditions in the main overview console query. And so I checked basically for how selective this was, and we wound up creating an index on these three columns. And the overall query cost went down further to 273. And we're no longer seeing, as we saw before, a full table scan on 976. We're now seeing that it's picking up the index, and the query cost has pretty much gone down. There's no longer doing a full table scan, it's picking up an index, and the query cost has gone down from like 361 to 273. So in this case, we basically looked at the two big hitters. One was on help desk, and the other one was on, in this case, was a problem. And we got the overall query cost down to 273. In summary, what I would suggest is we didn't do this part but in summary, what you want to do is you would adopt the same iterative approach for the other operations that are high in cost. So in this case, we had two of them. I took care of two of them by creating the appropriate indexes, got the query cost down tremendously from like 3,600 down to 273. The other test, that is the acid test, is if you were to run the SQL in SQL Plus or in SQL Management Studio and get a time for that. So I would run it 2 or 3 times, get the average time for the SQL before you start the tuning process, go through the tuning process, create the appropriate indexes, and then run it again in SQL Plus or in SQL Management Studio to basically get not just the reduced cost, the new cost, but also what that reduced cost translates to in terms of timing. Because, for example, the initial query, untuned query, might take 40 or 50 seconds to run, and then after you tune it like I just did, the 40, 50 seconds might come down to 7 or 8 seconds, and this 7 or 8 seconds eventually translates to the user's overview console performance, because the 7, 8 seconds might eventually translate to a 9 or a 10 second console load time, because there are some time spent, for example, in the network, some time spent in refreshing the screen, depending on the browser you're using and how long it takes to, for the browser part of it, the JavaScript code and all of that to execute. So eventually a 7 or 8 second SQL in the database might translate to maybe an additional 1.5, 2 seconds more. So again, you have to remember that these overview console load times are also heavily dependent on the user that is having performance issues. An admin user usually tends to have far better performance than a user that has a few roles, is part of a few groups. And that particular user that's part of a few groups definitely has better performance than a user that is part of 100 or 50 or 70 groups. So again, that's your caveat emptor. Basically, the more the groups a user is part of or companies a user is part of, you might see slower performance for that particular user. References, simple references, Oracle explain plan, what is the explain plan, and how to go about generating an execution plan for a query and how to use it to tune. Something similar in SQL Server, how to do query tuning in SQL Server using SQL Management Studio. These are additional resources that you have for, BMC, contacting BMC, technical support, knowledge base articles. And that is the end of the presentation. Thank you.